So here's another puzzle. It's really what's called a counting problem. So you're going to think about um, little boxes that look like this. And we're going to imagine that we have 3 of them. And you can either put them like this in a row, or with 3 boxes, you can put them like this. So the rules are that the boxes have to be touching one another flat, like in the way that you would expect to do it, where if you were like stacking them, like you can't do this, right? You have to do this. Now you don't have to worry about gravity, right? This would be okay. But what we're going to say is that this is the same shape as, say, this one. So turning things around or flipping them doesn't make it a different shape. Okay, so when you have 3 boxes, right? There's 2 different ways that you can connect them up like this. Now, what if you had 4? Right? If you had 4 boxes, certainly one way that you can do it is like this. One way that you can do it is like this. One way that you can do it is like this. And like this. Is that all the possibilities? I think it might be. I might have missed one. Okay. Then we can do 5, and so this is the game. You want to see if you can figure it out for like 5 and 6. How many different cases are there? So for 5, one example would be to have 3 like this, and then 2 like that, right? But there's going to be a lot of examples for 5. So here, when there were 3 boxes, there were 2 ways of doing it, up to reflections and rotations is the way that we say it. And when there's 4, unless I forgot one, there's 4 ways of doing it. And now what I want you to figure out is how many ways, how many different configurations of the squares are there when there's 5 or 6 or 7 squares. You can go as far as you want until you get tired of it. Then what you can do once you have those lists is you can see if there's ways that you can put these shapes together and to make another shape. So for example, here there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? There's 16 boxes. There's 4 in each one of these, and there's 4 boxes. So the question is, can you put these shapes into a pattern, like into something that looks like this? So there's my 16 boxes that make a square, and then you might say, oh, I'll take this one and put it here. It's good to do it with like maybe different colors or something. And then the question is, can you use the other shapes to fill this in, right? So, the answer might be no, because here there's 3, there's 2 different ways of doing this, and over here, so that's a total of 1, 2, 3, 4, 5, 6 boxes, right? And 6 is like 3 times 2. That's one way that I can make a rectangle, not a square, but a rectangle. But there's no way to put these 2 things into that box, right? So these things in math, all of these shapes are called polyominos. Kind of like dominoes, but there's more than dominoes look like this, right? So instead of just 2 boxes, there's more. So that's why it's called polyominos. So these are the triominos, these are the quadominos, and so on. Okay, now to make this just a little bit different, you can do something else that's called integer partitions. Okay, so this is sort of a different story here. So for any number like 4, you can think of all the different ways that you can add up integers to get 4, add up normal numbers to get 4. So 4 can just be 4, or it could be 3 plus 1, or it could be 2 plus 2, or it could be 2 plus 1 plus 1, or it could be 1 plus 1 plus 1 plus 1. Now, it doesn't make any difference, like if I say 1 plus 3, that's the same as this one, right? So we're not going to count it separately if you've just changed the order of the numbers. And one of the ways to keep track of things is just make sure the numbers start from higher values and then go down to smaller values. All right, so now what we're going to do is we're going to make a polyomino out of each one of these. So for 4, it'll look like this. Right? For 3 and 1, I put 3 in the first row, and I put 1 in the second row. For 2 and 2, I put 2 in the first row and 2 in the second row. For 2 plus 1 plus 1 plus 1, I put 2 in the first row, 1 in the second row, 1 in the third row. And in this one, I put 1 in the first row, 1 in the second row, 1 in the third row, and 1 in the fourth row. Now you might say, wait, this one and this one are the same polyomino. And you're right. Over here in this game, you would have been allowed to turn it around and make it the same. But here, they're different. This one and this one have the same shape, but they're actually considered to be different when you do when you do this. So you want to you have to make, basically you start from the top, and you always make sure that you push the blocks into the upper left-hand corner, right? And there's a row for every number, and you go down like this. So this is 2 plus 1 plus 1, right? And that's different than 3 plus 1. So I guess all I'll say now is that this one's not called polyominos, it's called integer partitions. So what I want you to do is take the number 5 and see how many different ways can you break up the number 5. How many different ways can 5 be decomposed into adding various numbers together, making sure that you take the big ones first down to the smallest ones. Okay, I think that's it.